Hi guys, it's Mark Montfort here from ABM Systems. I just wanted to create a quick little video, and actually might not be too quick because I'll go through quite a bit of material here, but it's to cover off on the talking points user group discussion that we had on February 12 this week. In this talk we focused on Qlik and also the data science type tools that you can use with the product. The page that I've got here that you can see is the meetup page for that. And we will run these every second Tuesday of each month. So the next one will be the second Tuesday of March. So keep an eye out on that one. But what I wanted to do was go through the presentation that we actually went through on the day with the clients and other users of Qlik. So whether you're a client of ABM, just a user of Qlik, or from anywhere else, and just are interested in what Qlik is doing and how data science tools work with that, and what we're doing here at ABM, this is a good talk for you guys to have a look at. So in terms of the intro to data science at ABM, here's a couple of the contents. TLDR stands for too long didn't read. It's just a nice summary of what it was that was delivered there. There's a bit of an introduction to what was in this course. Python examples, as that's a tool that we'll focus on, but it definitely works with R as well. And then also the integration with Qlik Sense and also how to get started. So this PowerPoint that I'm showing here was actually the one that we went through with the clients and other users on the night. So you'll actually get this in the show notes as well at the bottom. So part of the too long didn't read, as you can see there, what I wanted to really show and what we wanted to show at ABM was that it's really easy to get started with data science activities. It's not something that is far-fetched, and it's something that you can start with sooner than you think. Getting started is free. You can download Qlik Sense desktop for free and just start playing around on your home computer or your work computer, as long as obviously you need to get IT probably involved to make sure you can download that. You need to download then Python or R, get some free sample code from whether it's GitHub, Kaggle, DataCamp, etc. And then there's also a link that I'll show you of how Qlik have linked in both of these types of tools so that you can take advantage of the types of capabilities that data science people currently are the only ones really using. So learning this is easy. There's a lot of materials online. Google's your friend here. Data science tools are really good for standalone and ad hoc analysis, but getting things done in a larger number and putting code into production means that you need tools, and in this case one of them could be Qlik. And definitely talk to ABM about data science activities that you want to do in future. So why data science? I guess it's really popular. There's a lot more jobs. It's a lot of not necessarily hype in the industry. There's a good reason for why there are data scientists out there, but what we want to do is dispel the myth that it's only for them to be able to do stuff. I think we combine what data analysts, business analysts, and just people that are playing around with data are able to do, and show that you can actually start doing some of the more easier data science type activities, and definitely it's going to push the conversation forward in terms of what your company should be doing with advanced analytics. So data science is not just necessarily for advanced analytics. Tools typically in that space can be used to actually solve simpler problems as well. Now ABM also has a focus on data science, and instead of just the software and the analysis and problem solving actions, we actually want to really understand what you guys are trying to do with the businesses that you're in, and just how we can use the tools, whether it is Qlik, whether it's Power BI, whether it's some of the data science tools, just what we can do to solve your problems. We're very agnostic here at ABM. From here, what we'll actually go through is a couple of the examples. I'll stick to Python in this case here. You can see some of the benefits there for the data science tools. It's typically open source, which means you can get started for free, whether at home or at work. It allows you to have agile development. If you've got data, you can just start playing around with that and developing models and algorithms, and even doing like what I do, which is copy a lot of code that's available on GitHub or Kaggle or other data science courses like, say, DataCamp, and just learn how to do it from playing around with the data. And obviously there's a lot of textbooks and things that you can read to get into that. You can read some of the other points there on the benefits of data science, but some of the important ones is that it allows you to get really up to speed a lot quicker than having to wait a longer time to do analysis that might be too hard in tools like Excel or Qlik, because they have limits in terms of the capabilities of what they can do statistically. And it also allows you to get into this process of doing rapid prototyping, working out what works and what doesn't, importantly, and then going ahead and putting something into production. So it's really good for teams that way. So why open source? Well, first of all, it's fast to market. You've got this ability to jump straight into the data, as I mentioned before. You can take advantage of best-of-breed innovations across the open source community. It allows you to prove without significant upfront investment, which is really important in this rapidly changing and fast-paced world full of data. It helps you understand the data before productionizing, which is also quite good. It leads to further analysis and questions as well. So you can conduct further analytics, and you can also perform data science on a variety of different tools as well. So common use cases you can see there, whether you're in manufacturing or retail and consumer or energy and utilities or even financial services, which is where my background's from. You can see there's a lot of types of things that you can do with data science and with Qlik. Python examples. Okay, so what I'm going to do is go through a couple of these examples, and this is using Python via Jupyter Notebooks, which is one of the popular ways of going through Python. So I'll show you guys that there. So let me just skip over to that part of the talk. Okay, so in this part, these are the couple of projects that I've been working on here at ABM. These are all just running on my local machine. That was one of the questions that came up, whether this was running locally or on a server. You can do both. In this case, it is just local. So one of the first ones I was going to show was here is some, this is actually a course that was put together by the guys over at Data Camp, and you can see them there. I've included links to where I got all of these things from in the show notes as well. So as you can see from the talk, you can see that there's links at the top of each page there. So in this case here, for one of the stock forecasting and modeling tools, and in this case, the algorithmic based trading one, because I'll focus on the finance ones first, you can see the links there, okay? So just going back to it, there's a couple of things that are typical of Jupyter Notebooks. And just before I go forward, this is Jupyter as it's presented in the Anaconda Navigator. What you want to do is download Anaconda, and you can do that from, and again, all of this is included in the show notes, but you've got this Anaconda distribution page. So what Anaconda does is it packages up all of these different ways that you can use Python or R and do some data science work. And you'll see soon why they call it notebooks, because of the style that it's presented in with the Jupyter Notebooks page. But you can definitely get started by downloading this on Mac or Windows or even Linux. And if we go back to it, what I do is then go into launch this Jupyter Notebooks page once it's started. And then once I'm into it, I'll grab this example from online. One of the first things that is done is you need to import the different libraries that are going to be useful for the type of transactions and analysis that you're going to be conducting. In this case, I'm using pandas and NumPy to do some statistical analysis. There's another one called datetime, and I'm importing matplotlib, which is one of the more popular libraries for doing visualizations. Okay, so there's a few things that they need to set up at the start. In this case, I'm reading from Yahoo. I'm getting a ticker code, in this case TSN, which stands for Tyson Foods. They're a poultry manufacturer for those, or manufacturer, they're a poultry producer. So they breed chickens and sell those for those that are interested in. I'm pulling data from 2015 up until 2019. And the reason I do the tsn.head after I've defined this is just to see what's in the data, to make sure that I'm actually getting something back. Yahoo Finance and Google Finance and all of these other types of ways of pulling data from the internet. There's a lot of information about these online, so you guys can read up on that. There's a couple of notes that are in here, working with time series data, what you can actually do with it. In this case, I can select, say, only the last 10 observations of the close. I can change the type there. I can print out, based on the timestamps I'm looking at, what just some of the observations were. And as we scroll through, you can see here I'm doing some other calculations, and this is all based off the Data Camp course. The idea with this was to conduct some financial analysis, and it's in this notebook style fashion, where you've got a mix of text, you've got a mix of code. So just like when you were studying at uni and you had like textbooks and you would have information and pictures on the page. Unlike that though, when you actually go through this, I haven't run the code here, but if you actually were to run this again, you could update the numbers that are coming through. And the reason why it's really nice in doing something like this is because you can actually change some of the code in the text and actually pull back different companies or pull back different types of analysis. In this case, I'm looking at a plot of the adjusted close for this stock over time. And the thing that they were trying to do with this one was to put in some rules so that, and here we're looking at two stocks. So this is another poultry or chicken producing type company called Sanderson Farms. So Sanderson Farms versus Tyson Foods, what the distributions were like over time. So we see these nice bell curves. What they were trying to do was to build in this case, a way to trade the stocks. And I'm not advocating for this necessarily. This is not stock advice, but it just shows you, if you've got a time series of data, you can put in certain rules and see how those rules would have affected, I guess via what we call a backtest in finance, how it would have affected historically things that had gone on, and it can help you decide what you might want to do in future. All right, so you guys can go through the data camp course to really understand what's going on here. But in this case here, we build a simple trading strategy using Python based on long run and short run moving averages. We create those moving averages first, and what it's showing here are days when it would trade the signal or not. So there's ones and zeros there to mark that. And you can see here where there's crossovers between the short run and long run averages. And the idea is that when the averages cross over, it's either going to buy or sell. In this case, it's buying where it's green, it's selling out where it's red. So ideally, you'd want to buy and then sell out at a higher place. You want to buy low, sell high. All right, that's the way you're going to make profits. Sometimes it doesn't work. In this case here, it's sold out, it's gone flat, sold out, it's gone flat. It's bought here, it's actually sold lower, so it hasn't worked there. But there's situations, for example, this nice, really big trade where it's bought it at this part here, which is in 2017, so late quarter 2017, and it's sold out just in early quarter 2018 for a tidy profit at the time. You can see here, if you use the data analytics tools like Qlik or Tableau or or Power BI, this is not interactive. There are ways that you can actually make these charts interactive with Jupyter, and whether it's Python or R, you can actually make your stuff interactive, and you can make them, you can kind of turn them into dashboards as well, but with limited effect. But in this case, it's not. So that's one of the potential limitations depending on how you're doing your data science there. And then also you can see the compound annual growth rate at 100%. So that actually works out really well. There's another couple of things that you can do with Python. In this case here, I'm looking at some loan and credit distributions. We can look at some probability plots, so some advanced statistical things that you just don't typically get out of your normal data analytics and reporting tools. They even present it in like this kind of dashboard looking plot, and what you can see is there's a positive correlation between credit and income. So doing this type of analysis on the data that you've got, depending on your industry, it's really nice to actually do it in a tool like Python, but it does have its limits. This is an interesting one here where we are doing a time series forecasting. I've actually pulled some data. In this case, it's actually from a site called Quandl, QUANDL.com. I'll go to that, and there's a link in the show notes anyway. But Quandl were recently purchased by NASDAQ, but prior to that, they were a way of you to get financial data, whether it's macroeconomic statistics, data from the markets, or data from various data providers that are putting stuff up there. In this case here, I'm looking at Amazon's price history and volume history. There's something wrong with a plot here that I've created, so I've changed what was in the initial example. So it's just got that red line going across there, but just ignore that. You can see the trend of where the price has been. This is around October, where the prices have dropped off for most stocks across the globe, but they have recovered slightly into 2019. The point with this one was that there is a way of doing forecasting. Traditionally, there's quite a few ways that you can do time series forecasting. One of the most popular was the ARIMA, A-R-I-M-A function, and that auto-aggressive type function was used probably by most tools. Even Power BI has an automatic way of doing ARIMA type forecasting within its tool. However, the data science team at Facebook introduced something called Profit. And the good thing with a lot of these innovations, whether it's Facebook's data science team doing Profit or others putting their own kind of tools out there, Uber recently released and put something up on GitHub. The point is that these guys putting stuff on GitHub and sharing it with the community means that it's a lot easier for people to start utilizing those and putting more things on top of that by sharing and taking what they call forking out of GitHub and taking that code and actually expanding it to do further things. In this case here, with the Facebook Profit forecasting tool, we've used that to forecast where Amazon, in this case, share price is going to go going forward into 2020. Whether or not it actually does that, it's up to the markets. This is definitely not financial advice, but it is just looking at something that could potentially happen based on an algorithmic way of looking at share price. And you can do that kind of stuff with data science tools. So going back to the presentation, you can see there that data science tools are really quite good at getting started and playing around with data, whether it's data from just CSV files or you're connecting it to other things there. But the point with that, and here's some other visualizations where they're looking at Uber trips in New York, and also using Plotly, which is another we use Matplotlib and a lot of the other examples there. Plotly is another way of doing things as well, and they've got some cool features as well for geospatial analysis. But whether you're doing time series charts, bar graphs, you're looking at tables, or you're doing these geospatial maps, the point of this is that with data science tools, typically they are sitting within a specialized team within your organization, or it's only amongst a few users. You're not going to be able to get necessarily the majority of people that deal with data in your staff able to use tools like this. For one, you need to, unless you actually add on specialized tools, you need to actually rerun the entire code before you're going to get new results. There are ways that you can change that and put filters on there, so it's a bit more of a dashboard-like experience that people are used to typically, but it does require add-ons there. But that's okay. I mean, the important thing is that there's a lot of really advanced analytics that you can do with tools like this. So if we look at Qlik, one of the interesting things is that it's actually built for this type of guided analytics, and you can see there they do corporate reporting, guided analytics, ad hoc analysis, visual exploration, and all that kind of stuff. And we'll switch over to Qlik right now, where I can find it. There we go. And this is my Qlik Sense desktop hub, and there's quite a few things that are on here. There's some examples that you get here from Qlik. So if we look at, say, the retail store analytics, this is Qlik Sense. A lot of people might only be used to Qlik View, which was the older tool and much loved. But Qlik Sense came about in 2013-14, and when it was released, they've added more and more features to what it's able to do. It's actually more built than previous tools like Qlik View for HTML type analysis. So when I say HTML, it's more built for modern web pages. So it actually sizes. So if I change that, it auto scales. And this is not something that Qlik View could do. So I can pick, say, a couple of different store IDs, nice and interactive. I can pick different areas. They've only got like a few kind of filters on the page here, but then I can, change some other things. So if I want to look at, say, fixed and actual in terms of product, see how that affects the analysis, and it's nice and interactive. I can expand these things. A lot of tools do this kind of stuff. This is what I would call, say, exploratory or standard analytics. But taking it further, what a lot of these tools don't do, they might have some features in terms of, say, doing a tiny bit of forecasting with ARIMA, for example, but they don't do some of the more advanced, say, machine learning or other ways of doing forecasting and prediction modeling. So we'll show you how you do that kind of stuff with Qlik and Python. So if I just go back to the presentation, and we'll continue that. The old way of doing things in the past, when you didn't have these tools connected, and I guess they say the old way, but it's even the current way for a lot of people, is that you would have the data scientists doing a lot of the work there in terms of data acquisition, preparation, data creation, selecting the type of model that's appropriate based on the data and the type of tools that are available at the company. Then what you had was that the results interpretation was up to the business analyst. They might create reports on the back of that. They would ultimately be limited by what's provided to them either by IT, the data scientist teams, or what's been made available in terms of the analysis that they know how to do in terms of their skill set. And then at the end, you've got the action steps that business users take. And so if you think about it, a lot of this stuff here on the left-hand side takes time, and even in the middle. So before business users can actually take actions, there's a lot of stuff that goes on in the background before they can even get to understanding what analysis has been done and being able to harness that information and actually use that for the benefit of the company. In the new world, if we have this way where data science tools are actually being used in production, they're, whether you want to call it productionized or they're operationalized, they're just used in ways that are not so siloed off with the data scientists here on the left-hand side. The data scientists of the future should be involved in a lot of those things, but hand off a lot of that so that what you end up having is that they can just focus on things that they're really good at, i.e. model creation and also governance oversight in terms of the types of models selected. I have experienced, I guess, firsthand where certain types of analysis were thought of as being quite good, but the people that were doing them didn't know about things like overfitting data and selecting the wrong type of analysis to try to fit an equation to solve a certain problem. And that's why it's important to really have the data scientists there focusing on those things instead of things that they had used to be doing in the past. So things like data acquisition, preparation, model selection even, that should be done in conjunction with the data scientists, but more on the business analyst end doing that. And even with parameterization, where they're selecting what types of parameters, fields, for example, that are being used to create predictions, it should be more on the business analysts that are closer to the ground where the data is actually coming from. Okay, and then at the end here, you've got a lot more tools that are being given to the business users. They get to do data selection and they can do some basic parameterization because maybe they're dealing with the end users or they're on the shop floor. They get to see things firsthand. And so it's more of this communication on the right-hand side that's going to be important for them to be able to take actions because they get the data where and when they need it, as in, when they need it, and it's really important to try to move things towards this type of generation of doing things. The benefits of Qlik with advanced analytics are that the data scientists, as we said, they can build the advanced models and calculations. The business decision makers can utilize them in the context of, in this case, because it's Qlik, it's associative exploration. And then in terms of the analytics, these are calculated and visualized in real time, rather than having to send off analytics and wait for that type of stuff to be analyzed before you can get any results. And then you just twiddle your thumbs and you have to wait before you can take actions. So introducing the advanced analytics integration with Qlik, what they've done is built a third-party advanced analytics engine through server-side extension APIs. There's full integration with the Qlik Sense expressions and libraries. There's a bunch of connectors that can be built for external engines. Some of the examples are here. This is one of the GitHub and R and Python connections. Then also this is one that a guy named Nabil, who works for Qlik in Melbourne, Australia, has put together, looking at a way that it can actually be used in conjunction with PyTools. And I'll show you that link. Now, how it works effectively is that the user would interact with the app. And you saw before how I was clicking around in Qlik Sense. So that is the interaction side of things. When you connect it up to a Python, in this case, which is what I'm using, connected up to Python, you're using the Qlik engine to build a hypercube and get that recalculated so that you've got this new context. That in-context data is then sent to the external engine, in this case Python. The external engine runs and sends the results to Qlik, and I'll show you how it's doing that. Then the Qlik engine combines the hypercube with new data, and that combined hypercube is visualized in real time with the user. And so the type of code that's used there, for those of you that are used to Qlik code or even code from other tools, the way that they typically work is that you would have some sort of expression or measure, depending on what you want to call it. It might be sum and then open bracket sales, close bracket, or average or AVG of open bracket sales and then close bracket. And there's some nuances to that, whether or not you're doing in QlikView, say set analysis, or you're doing some sort of filtering with Power BI, but they all follow the same kind of line. In this case, there's a bit more complexity to it, and the reason for that is that over here we need to actually name the extension to the third-party application. This example uses R, but in the ones that we're going to see live, it's actually Python, and they call it PyTools there. Then you see this function that says take this text and pass it back and let this end server evaluate it. So this script eval, it then needs to pass through the first line of the R script, and then it also extracts other parts of what is in the Qlik Sense application. So it needs to read fields from the Qlik Sense application and pass that into R. So for example, this sum of births per month would be a field that sits within Qlik. and it needs to pass that back into a function that's been defined in R in this case, or in Python. So the way that you can define functions, when you go through data science courses, you can see how they do that type of thing there, and you would be able to do something similar. Or in this case, what I'm advocating for is that you take the examples that have been provided by Nabil on his GitHub page, which I'll show you, and you can take that further and do other types of things once you get to understand how all of this works. And so in terms of the demo, first of all, what I'll do is show you the GitHub page where I downloaded this from. So I already had Qlik Sense installed on my machine, but you can go to download that from qlik.com and just basically go over to where they've got the navigation page for downloading Qlik Sense desktop. You might have to sign up, but that's okay. It is free. Qlik Sense you do have to pay for once you get to an organizational kind of state where you need to share things amongst a number of users, and you're trying to do stuff on a server to do that. So look, it's really easy to get started. So if you're thinking about it, go ahead and try. Over here with the GitHub page, there's a couple of things you need to download, so you can just clone or download that. I downloaded the zip. He's got an introduction here in terms of what you need to do on your machine if you're running it on desktop, and also a video of the types of analysis that's done. So it's really great. If you guys want to chat with Nabil, I suggest contacting Qlik or your partner, reseller over there at basically whatever state you're in, or in this case country, depending on who sees this video. Someone should be able to help you out. So there's a couple of things that you need to do depending on whether you put it on server or you're running it from your desktop, but just go through these steps. They're really straightforward. They really are. I'm not a coder necessarily. I'm not all that good with data science tools. I am learning, but I was able to pull this kind of stuff together. Okay, so if I can do it, you guys definitely can. And in terms of the usage here, he's got some examples. And for example, if I click on the forecasting one, it takes me to another page, which is the forecasting app that he's built, in this case using Facebook's profit algorithm, and you can see here how it actually works and the additional parameters that you can change. Okay, so all of this is nice and available on the GitHub page. If we go back to Qlik Sense, in this case here, I've got a couple of applications open. Because I was on the profit one, let's take a look at that. So you guys saw before how I did the one with profit, which is the Facebook's data science way of doing forecasting on time series. The way that I did that was with Python before, so that was sitting in the Anaconda notebook. So this same kind of algorithm, I'm using different data here, but this same type of algorithm that's conducting the forecast of what's going to happen going forward with this time series, that's the same one that I'm actually using here, but this time it's within Qlik. And just to show you the context to see that you can actually see this as Qlik is running, the key here is that, okay, so in the middle, we've got the, in the orange area, we've got the actual, what actually happened with this time series. In this case, I haven't selected anything, but I will. This is the average of all of the guys, all of the different hospitals here, okay? The middle is the forecast area, and then there's an upper limit of the forecast and a lower limit of the forecast. So if I select something, in this case, say the Alfred Hospital, you can see here that on the side, Python is actually running in real time in the background. It's not sending data to a certain file, exporting that, waiting, whether it does it manually or via macros or something like that, or you're even sending it to a team. This is actually doing it in real time, right? So you can see it's done its detection there, and it's rendered that using the hypercube in Qlik Sense, and we can see here what the forecast is going forward based on that time series. Okay, I can pick, say, another hospital, say Ballarat. It's going to do the same thing there again. So this was just to show you that you can actually see that it is running in real time. Okay, so let's just expand this again. Okay, so I've just done something there. If I select it again, I think it's because I just rendered the page to full, so it wasn't going to calculate. So this should give us a calculation here. Okay, maybe not. Try one more time. It's a great thing about doing live demos, or in this case, a live video recording. Sometimes they do not work out, but we have one more chance, and there you go. Okay, so it was a little bit sensitive as I was making selections there. It was thinking that I was maybe changing the selections or something, but that's okay. That is the profit example. That's one of the ones that's available from the GitHub page. So I'll just close this one down. Here's another one where it's actually using scikit-learn. Scikit-learn is one of the more common tools being used or ways of doing machine learning. And what they're doing in this case here is looking at a a mock department or company and looking at whether or not there's going to be attrition or employees leaving. So if we select, say, a couple of departments, and based on whether there's like travel, non-travel, travel frequently or whatnot, I can make a couple of these selections, and based on the type of job role that the person has, based on the selections that you made here, is there going to be attrition or not? And it's using all of these different factors and historical data to conduct basically a machine learning style, basically a way of analyzing whether or not there's going to be attrition going forward. And it does this prediction here, so you can see there's yes, no for some employees, and it's got probability rates. So in this case, it's 97% probability that there's not going to be attrition for this, and only 2% that there is. Or in this case, it's the other way around. So it's more probable, in this case, close to 60% that this person's going to leave as a healthcare representative. They've only been at the company for 1 year. They've been less than a year in terms of their current role. Year since last promoted was 0. So based on that and based on historical data, someone that's this age and male and in the research and development department and their job role as a healthcare representative in this fictitious company, they're more likely to leave this role than others. So that's an interesting one to do. And then some of the other ones in here, you can see this one's just running simple correlations. So I can select, say, a different local government area group, and you can see how things change there. And then there's a page here which shows all of the different correlations across there. I can make different selections here. I can say change it to rural city, for example. You can see that Qlik runs that. It is talking to Python in the background to do this. One of the things that you'd be able to see as well here is if we take a look at the data that's behind here, what I was going to show you was what the expression actually looks like. So if we just open that up, so this is normally what you would see here is some sort of Qlik or Qlik View or Qlik Sense. They're both the same, or it's even similar across other tools, but you'd see something like this, right? Sum of sales, which is what I was talking about before. Okay, so that's usually the type of expression that you'd see here, but in this case, because it's connected to Python using this API, they're calling something called PyTools. They're running a correlation defined function that comes from Python. It's pulling across a couple of variables and it's telling it to do a Pearson type correlation. There are different types of correlations that you can use, but it's using the Pearson one in this state here, but that's how it's done. There's nothing for you to actually change in terms of the load script. It's all on the measures end or expressions end, if you want to call it that, okay? So that's the correlations one. There's quite a few other examples that Nabil's got. In this one here, this one's actually looking at different accidents across Victoria. So let's, for example, say that we want to look at just metropolitan type regions so that we can drill down to the data, look at the severity. Let's say that, say, non-injury accidents and maybe other injury accidents. And let's pick another couple of things. So we'll look at just a certain set of areas. So we've got a couple of results there, but it just shows you the all of these things, all of these different accidents, just as the same color. If we want to do a scan on that, in this case, it's going to cluster based on the different factors that are available to the model. It's going to try to provide a cluster and look for where accidents are similar. So you can see the colors change there. So based on the factors that were involved in these accidents, the ones in red are more closely aligned with each other, as are the ones in blue, which are they're not. Okay, so you can do clustering whether it's on your customer data. It doesn't have to be geospatial, but the fact is that you can do this kind of stuff in real time with Qlik. So it's a really good way of doing things back and forth, and it makes data science a lot easier. We can actually put it into a production type tool and not have to just keep on sending around a data science type notebook, whether it's in R or in Python using Jupyter notebooks or not. Okay, so as you can see there, these were the examples that we went through. In terms of getting started, now the foundations of a data scientist, they typically call these guys unicorns because they've got typically subject matter expertise, maths and statistics, or computer science. Now, you don't necessarily have to have all of these. You might have one and you're working on some of the other tools there, but the point is that technology is making it a lot easier to actually get started by learning, and I'll show you some of the courses that you can do on this. and it's actually making it easier for these technologies to be more used across the wider spectrum of your business than just a single area being, say, the data scientists or analysts. First of all, what you want to do is install Anaconda. So I showed you the download page before. You would want to do this on a project that you're actually interested in. I find it really hard to learn on things that I'm not necessarily aware of or understanding in terms of the field where they come from. So if you've got data that relates to stuff that you're interested in, then go ahead, or even better if the course actually relates to something that you're doing. So for example, my background is finance, and I'll show you some of the finance courses that I've been doing with machine learning and Python, etc. So you'll learn all the tools that you need for these projects. So some of these could be like pandas, NumPy, or visualization packages, or machine learning. So like scikit-learn if you're doing Python. It'll be very hard if you're invested in it. It'll be very hard, but if you're invested in it, you'll learn what you need to do a lot more quickly. There's a reason to, say, get to that type of analysis that you want to do, especially if it's something for work or a hobby that you're really passionate about. Now, if you get to a roadblock of something, even if it's something that you're interested in, I think you're going to be more likely to succeed because you've got that passion to learn something, and the community can really help. So I would definitely Google. More likely than not, you'll probably come to a page called Stack Overflow. Stack Overflow is a great place for people, whether they're data scientists or just doing exploratory analytics, to find information about how to overcome a certain problem. The best thing to do afterwards is actually talk about it with your peers or people that you work with in terms of colleagues, and write about it, teach it, write a blog post. I'm doing this video here so that I can show people that it's actually a lot easier to get started than you think. In terms of where to get data, like I said, there's work sources. So whether it's work data that you have access to or you can request. Some Australian sources that would be good. This is not an exhaustive list by no means at all, but just some of the ones that I've just been using recently. One is data.gov.au, which is a third-party website where you can actually get a lot of information there. And then also you can look at the Bureau of Crime Statistics and Research. So there's a page there. Others are Kaggle data competitions as well. In terms of online courses, you've got Udemy, which you can look at. Some of the courses that I'm doing are investment fundamentals and fundamentals of data science, Python for financial analysis and algorithmic trading. There's some courses on Coursera. There's Udacity, DataCamp as well. Another great thing is the different podcasts that are available. So you can use DataFrame, which is by DataCamp, and you can look at something called Chat with Traders. Now that is a finance focused one, but one of the one of the talks that Aaron Fifield did there was talking to a guy from DataCamp, and while it's finance focused, it was really great for getting started with data science tools in terms of what they spoke about. So that's a presentation there. Just going back to it, just one of the things I want to show you before we finish up is just like in terms of, say, one of the courses one of the places where you can do courses. I'm doing this one from Udemy. So you can see here there's interactive Python dashboards, and there's Python for data science and machine learning. So if you just type in, for example here, this one I think is really great value. So if I look for a couple of the ones on Python, we'll just let that run. And what you're going to be able to see here is all the different Python related courses. You could say Python for finance, or put that in the search, but you can see, they run a lot of specials, right? And in terms of this one, for example, this machine learning one, what you see is that there's 41 hours material across 289 lectures, and all for the low price of $17.99. So I'm not trying to push these guys, but I think that is great value. But obviously there are other courses there, whether it's DataCamp, it's Udacity, it's Coursera, or it's even blog posts that people have put up. Another great area to look at is Kaggle. Kaggle.com, they run a lot of data science type competitions where they get collaborative, it's like a hackathon, people get given a certain data set, there's an achievement that they're trying to reach based on whoever's put up that data set, and there are prizes typically. So for example, you can see here there's like a FIFA 19, the game, the complete player data set there, and what people want to do with that. There's end of day data for Dow Jones stocks, which is a stock exchange in it's an index of stocks in the US. So you can see here when I click on that, you can see all the different data sources there. So Apple, BA, which is Boeing, Cisco, all of these, Home Depot, all these different companies that form part of the Dow Jones index. You've got a list of the different columns that are in that. So you've got dates, open, high, low, close, all these financial kind of metrics, and you can see some basic information about that data. Okay, so just over time, what the counts are. So that's really good because it shows you what's in this data. But most importantly, and this is what I've found is really useful for learning, is if you click on the kernels, you can see how different people have actually used this data to conduct some type of analysis, whether it is with R or Python or something else. So in this case, you can see here someone's done some stock market data analysis with Python. If we click on that, and this is how I find it, the best way to learn. You do the courses and then you go and find information that you can now play around with. So I can recognize here that this person's done it with Python, obviously from the name, but also from the types of libraries and how they're importing those. It's a little bit different if you're using R. And then if you download it, you can see here that once you put in certain folders, you can follow the code and copy that into your Python notebook. You can see what they've done in terms of the analysis, and if it's commented well, you should be able to follow along, and it is here. And the cool thing with this is that you can get started playing around with data like this, changing the analysis, putting in different data, putting in your own data, and running this very similar type of analysis that I guess what I've seen so far is typically most people think, and most organizations think, that this is only in the realm of the data science space. And it kind of is, and you need to understand what's going on here. You can't just do analysis and then throw that at a solution and think you've got something there. But the important thing is that you can actually take steps towards having a good understanding so you can be part of the conversation than not. So this is a really good example that you can look at, okay? So like I said, all of this will be left in the show notes that I'll present at the end of this. So when this goes up on YouTube or wherever the video is going to go, there'll be a link to some of the details, and definitely with this this presentation here. So all the best. If you have any questions, then contact the guys at ABM. Thank you.